Good morning, class 10. Before starting this chapter 1, I would like to remind you, according to the guidelines of CBSE, some topics have been removed. So, Unit 1, chapters, real numbers, Euclid's division lemma. Euclid's division lemma has been removed from the syllabus. So you will leave that topic, Euclid's division lemma. Now the second thing which you have to learn, fundamental theorem of arithmetic. So Euclid's division lemma has been removed from the CBSE for this from the syllabus, and therefore you don't concentrate on that lemma. Now you see fundamental theorem of arithmetic. You should watch that solution or explanation very carefully, and you will try to solve. Fundamental theorem of arithmetic. What is this theorem? Every composite number can be expressed as product of prime numbers. Composite number, I suppose you know very well, the numbers which have more than two factors. The smallest composite number 4, then 6, 8, 9, 10, 12, like that. And prime numbers you know very well, the numbers which have only two factors. So every composite number can be expressed. You can express every composite number in the product of prime numbers. Suppose two examples before you. 20 is a composite number. If I ask you why, because they have more than two factors. The prime factors are 22 into 2 into 5. What do you observe? You observing that 20, which is composite number, is expressed as a product of prime numbers. Now you see 35, 5 into 7, and number of examples before you. So you can understand this is called fundamental theorem of arithmetic, and this is used to find the HCF and find the LCM of the given numbers. Now you see for chapter will be saying exercise 1.3. 1.3, terminating and non-terminating decimal. Without actual division, without actual dividing, how can you find out whether a rational number given will represent terminating or non-terminating repeating decimal? Although by dividing, everyone can find out the rational numbers terminating or non-terminating. If remainder 0, this means that division terminates. Division is completed. That is called terminating decimal. And if we continue dividing a rational number by other rational number, and we are not able to get the remainder 0, so that is called non-terminating. If the prime factorization of q of a rational number p by q is in the form of 2 power n or 5 power n, that p by q, that rational number will represent terminating decimal. That will be terminating. And if you can verify by dividing numerator by denominator, and you can easily prove that this rule is okay. And if q, the prime factorization of denominator, is not in this form, that will be non-terminating repeating this one. So my dear student, you will remember this rule. If the prime factorization, suppose you have 17 upon 40. If I ask you, this will represent terminating or non-terminating this one? So how can you find out by using the rule? You find the prime factor of denominator. So 40, the prime factorization of 40, 2 into 2 into 2 into 5. What do you see here? We see the prime factorization of 2 is in the form 2 power n. You can write in the form power 2 cube and 5 power 1. So we observe the rule is applicable here, the rule is satisfied here, and therefore this will be terminating this one. And if you divide 17 by 40, that will be 100%, that will be terminating. So this is the rule, and with that rule you will try to solve 1.3. One important thing I would like to express you, that how can you prove root 2 or root 3 or root 5? Suppose prove root 5 is not rational number. Is it rational or irrational? Irrational. Not rational. How can you prove? Now you see, contradiction method, let root p is equal to is a rational number. इसको मान लेते हैं rational number है. Prove करना है rational. So by supposing rational number, we follow some process, and this will be the contradiction during the process, and then you can prove that root 5 or root 2 or root 3 or root 7 like that, they are not rational number. So like root 5 is a rational number. Root 5 rational number, that can be expressed in the form of p by q. P by q is not an important part. You can suppose a by b or c by d, nothing doing with that. So root 5 equal to p by q. Squaring both sides, you will get 5, and this will be p square upon q square. By cross multiplying, you will get 5q square. What do you observe here? This is the multiple of 5. This means p square divide 5. P square divisible by 5. This is the meaning. Any multiple of 5, that will be divisible by 5. Very simple. P square divisible by 5. And p is also divisible by 5. Now suppose light, again be light root 5 p by q, you see again, root 5, you have to prove not rational, later it is a rational, root 5 equal to p by q, according to the definition of rational number, squaring both sides. Now p is equal to, suppose 5r, because this is divisible by 5, squaring both sides, you will get 25 as r square, this is second, and this is first. What do you see from first and second? From first and second you see the left side equal to right side will be equal. 5q square is equal to 25r square. Dividing both sides by 5, q square is equal to 5r square. So q square divisible by 5. And similarly q divisible by 5. What do you see? We see that p and q divisible by 5. This means they are divisible by 5. It means, what does it mean? It means p and q are not co-prime. Co-prime, my dear student, co-prime are those numbers which have no common factor except one. One is common in every number, but except 1 if no prime factor. But here we see P and Q both are divisible by 5, so 5 is also common. So P and Q are not co-prime, Hence, this is the conclusion, because P by Q rational number, and if you write in the simplest form, so that these two will not have common except 1. But here we see 5 and Q, P and Q both have common 5, because both are divisible by 5. Hence, our supposition is wrong. Our supposition is wrong, and this is the contradiction, because we have supposed incorrect. It is a rational. Hence, root 5 is irrational or not rational number. So similarly, you can verify either root 2 or root 3 or root 5. So this is the method, I repeat. Question is, root 5 is not a rational number. Like root 5 is a rational number. Rational number, it can be written P by Q. Squaring both sides, you know very well, this will be 5 P square by Q square. By cross multiplying P square is equal to 5 Q square. What does it mean? It means P square divisible by 5, or 5 divides P square. So P is also divisible by 5. Now, like P is equal to 5R or 5X or 5Y like that. Squaring, you will get this from 1 and 2. What do you see? We see the left sides are equal, and therefore RHS will be equal. 5Q square is equal to this. Dividing both sides by 5, you are getting Q square by 5. Q square is equal to 5R square. It means it is also divisible by 5. So you observe P and Q both are divisible by 5, and therefore they are not co-prime. Because this is the condition for co-prime, P and Q should have common factor only 1. But here we see 5 is also common factor, so no co-prime. And this is the condition for a number is a rational number. P and Q should be co-prime. So this is the method to solve this type of question. And now you see combined equation. Combined question, how can you prove they are irrational? One more question. You see exercise 1.3. Suppose 3 plus 2 root 5. तो इसको भी suppose कर लेते हैं, like this is a rational number. Now this means root 2 5 is equal to P by Q. We find the value of root 5. So root 5 is equal to, what will be? P by Q minus 3 divided by 2. You simplify right side. LCM will be Q, and this will be P minus 3Q. This will be 2. Now you see the right side done. P minus 3Q upon 2Q is rational number. Why? Because P and Q are integers, and the difference of integers, quotient of integers, they are rational number. So this is a rational number, and therefore 5 is also rational number. Kyun? Because both are equal. So root 5 is also rational number, but it contradicts. We know that root 5 is, but we know root 5 is not rational number. Here, no need to prove root 5 is irrational. It is already, we know that. Root 5 is not rational. Therefore you write the result. We conclude, what do you conclude? We conclude that 3 plus 2 root 5 is not rational number. So this is a question And this type of question you have to solve like this. You suppose this is the rational number, this can be written P by Q. You transfer 3, so this will be minus. You find the LCM and you also transfer 2. So you are getting right side P minus 3Q upon 2Q. This is a rational number because P and Q are integers and 3 and 2 you already know integers. And therefore this term is a rational. Since they are equal, the root 5 is also rational number. But it contradicts that root 5 is not rational number, and therefore our supposition, we have, whatever we have supposed, that is incorrect. And we have supposed this is rational. No, this is wrong, and therefore it is irrational number. Understand? So these are the some questions, and I am sure you will try to solve and you will solve the questions. And once again, I would like to remind, if Plate's division lemma has been removed from the syllabus, रियल नंबर्स चैप्टर जो है उसमें से वो हटा दिया गया है. So that topic is deleted, and so we have to concentrate on fundamental theorem of arithmetic. Fundamental theorem of arithmetic, every composite number can be expressed as a product of prime numbers. I have just given the examples, and these are a few questions. And I am sure you will try to complete, and you will complete chapter 1, excluding Euclid's division lemma. Understand? So this is the method to prove any irrational number. How can you prove? In class 9 you have learned how can you represent this irrational number on a number line. But now we are learning how can you prove root 2 or root 3 or root 5 or root 7, etc. These are irrational numbers. So that was the method. And one more question I have explained is suppose 3 plus 2 root 5 rational number, irrational, how can you prove? So this is called contradiction method. We suppose just reverse of the question is in that particular problem. So like this is rational. Rational means this can be written in the form of P or Q. Find the value of root 5 by transferring 3 and 2. You are getting the right side P minus 3Q upon 2Q. And these P and Q are integers, and 3 and 2 you know very well they are also integers. The difference of integers, the quotient of integers, they are rational numbers, so this is a rational number. But root 5 is also a rational number, according to this process. But it is a contradiction because we know root 5 is not a rational number. And that's all. This is the solution. And I am sure you will try to solve and you will solve. Thank you and have a nice day.